Hello and welcome to this webinar on data usage to support area-based planning in areas beyond national jurisdiction. This has been organised as part of the ABNJ Deep Seas project, which is a 5-year project jointly implemented by FAO and UN Environment. The UN Environment component of the project looks at area-based planning and is led by UNEP-WCMC. This presentation will describe the importance of marine data and metadata, in particular how data can be used to support area-based planning in areas beyond national jurisdiction. I'll talk for about 25 to 30 minutes, and then we'll have approximately 15 minutes at the end for questions. So if you have questions, please write them in the chat box and I'll answer them at the end. Thanks for joining the webinar. FAO and UNEP-WCMC are working in partnership with the many regional fisheries bodies, as well as governments and academic groups that you see listed on screen. The project has a number of activities that involve 2 pilot regions. These are the 2 pilot regions for this project. And in these 2 pilot regions, we work closely with the Permanent Commission for the South Pacific in the Southeast Pacific region, and in the Western Indian Ocean, we work closely with the Nairobi Convention. Specifically, Component 4 of this project aims to identify and test area-based planning methodologies within these 2 pilot regions. Today's webinar is focused on data usage for area-based planning. So the first question we could ask ourselves is, who actually needs marine biodiversity data? And by this I mean all marine data, whether it's on biodiversity within national waters or beyond. Firstly, governments need these data for reporting on the state and condition of their marine habitats. Secondly, intergovernmental organisations and NGOs need the data for indicator development or reporting towards global targets. The corporate sector also need these data for environmental impact assessments, but also for management decisions. And finally, research bodies. Data can inform decision makers about the spatial and temporal distribution of marine biodiversity features, such as seamounts and knolls. They can also provide information on the state of marine ecosystems, for example, through ecosystem health indicators or stock assessments. Data, or lack thereof, also help in recognizing regional data gaps, as well as priority areas for biodiversity conservation. There are many different types of data, which can be classified in different ways. For example, by what they represent, when or how they were collected. One way of differentiating data is by their geographic scale. Global data contain features ranging over a global scale, which means trends are comparable globally. However, global data often come from many different sources, which means they were sometimes collected using different methodologies and with different accuracies. Regional data, on the other hand, is focused on a more local geographical scale, which means they can be more accurate and better suited for regional level decisions. Both types of data have their benefits and drawbacks, and it all depends on what the data will be used for. As well as different types of data based on their geographical range, there are also varying levels of data depending on the type, and these can be broadly split into 2. Firstly, there's the underpinning data, such as species distribution and habitats. These data then get used to create other data sets, such as ecologically or biologically significant marine areas, or Alliance for Zero sites. So these are a synthesized version of many data sets to decide whether, for instance, an area is vulnerable or significant. The combination of the data sets under certain criteria create the synthesized data sets in the box on the right. Having given a short overview of marine biodiversity data in general, I'm now going to talk about metadata. So what are metadata? To put it simply, metadata are data on data, which sounds slightly confusing, but it just means that metadata summarize the information on the data, and they provide meaning. Metadata are essential to guide the appropriate use of datasets and indicate what you're looking at. For example, if you have a map relating to a species distribution with polygons on it, you might not know if a polygon indicates species occurrence, their range, or modeled data, and so on. Without the addition of metadata, raw data often lack the contextual information required to understand the origins of the data and the types of analysis that they could support. So metadata are essential to guide the appropriate sharing and distribution of data. This is an example of the kind of standardized metadata sheets that we produce at WCMC. These were included in the 2016 Global Data Reports and have been adapted for the 2018 versions too. As you can see, there are different fields for information on the datasets. Here, the dataset in question is one on the global distribution of cold water corals. Our metadata sheet provides information on where this dataset comes from, why it was created, and what the limitations for use are. In this case, the data are observed data, and the limitation that can come with this is that often areas that show a higher number of records are areas that have had a higher intensity of research. To ensure that data are not misused, the assumptions and limitations affecting the creation of data must be fully documented. Typically, data are used by many people other than the producer. So metadata allows a producer to describe the resources so that further users can understand the assumptions and the limitations, as well as evaluate the resources' applicability for their intended use. The version and lineage, or how often the data are updated, is another essential field. Data are a snapshot in time. They represent a fact, in this case, the distribution of cold water corals at a point in time. So knowing when a data set was created and how often it's updated is really important. All in all, proper documentation through metadata will provide those that are unfamiliar with the data with a better understanding and enable them to use it properly. Good quality documentation will also provide data producers with a keener knowledge of their data and allow them to better manage and use them. Not all metadata fields are essential, and the essential fields may vary depending on the purpose of the metadata creation. So on screen, you'll see some examples of recommended essential fields. One of the most important fields in any database is a unique identifier, in this case, metadata ID. It's also very useful to have a web address for the location of the dataset if it's available online. Different users of the data will be looking for various bits of information depending on what they're planning to use the data for. So the more information, the better. As for most data hubs, a lot of the work carried out at UNEP-WCMC evolves around not only creating but also standardizing data and metadata. As you just saw, we developed our own metadata standard, which we apply to all marine and coastal data sets that we handle or host. To ensure sustainability of information collected, data and metadata should be recorded in a consistent format. On screen, you see some of the benefits of standardized metadata, some of which I mentioned before. Essentially, by having metadata on datasets, the datasets themselves can be more easily stored, found, shared, and reused. At UNEP-WCMC, we've pulled together marine datasets from all over the world, and we host them on our Ocean Plus website. This improves access to and use of marine data. Here you can see we have different sections to highlight what different datasets we have stored, each with their own metadata sheets. These direct you to the dataset itself and provide contextual information for the user, such as limitations and whether the data were observed or modeled. This also links to the World Database on Protected Areas, and the newly released Ocean Plus Habitats webpage also provides statistics on global coverage of marine habitats and the percentage of these that are covered in protected areas. So I've discussed what metadata are and the benefits of standardizing them. I've also highlighted some of the work that we do at UNEP-WCMC to bring together marine data sets and their metadata. I'm now going to talk about metadata storage, in particular the metadata inventories that we've created as part of the ABNJ Deep Seas project. In 2016, as part of this project, we wanted to identify global data sets that cover regional features within the 2 pilot regions. So our first focus was on global data. We published 2 technical documents offering a high-level introduction to data sets of relevance to areas beyond national jurisdiction. Each inventory identified data sets that reflect various characteristics of biodiversity. As part of these reports, we also created the standardized metadata sheets that you saw before, containing all the necessary information relating to a given data set. In 2018, we took this one step further. To expand on and complement the 2016 global data reports, we decided to focus on regional and national data sets for each of the 2 pilot regions. We wanted each region to be involved in producing these inventories and to learn about the barriers in data use and sharing that could potentially exist. These reports were led by regional data experts in each of the 2 regions. They're currently being finalized and will soon be published on the Common Oceans website. The aim of this was to identify what more local scale data sets exist and what the potential regional data gaps are. So each inventory lists what data sets are available and directs the users to the data set sources. In the Western Indian Ocean, a GIS consultant was hired by the Nairobi Convention to carry out this work with coordination from UNEP-WCMC. This approach was taken because we wanted to capture the region's perspective on data. Another important aspect of this work was capacity building. The GIS consultant visited us at UNEP-WCMC in Cambridge for 2 weeks to learn about our data management processes. In the months following this visit, the GIS consultant contacted different data holders to ask them for metadata on these data. They also carried out internet searches to identify further data sources. As this piece of work is currently in review, we just have some preliminary results that I'll discuss. More than 40 regional, national, and local data sets were identified from coastal zones to the high seas. These were split into 9 different data categories. Most data sets were found in the categories of regional biogenic habitats, such as coral reefs and mangroves. Preliminary data gaps were identified in species habitats and biogeographic classifications, where only very few data sets were actually identified. The next steps for this piece of work will be the finalization of its review, as well as a final validation in the region. So if you're a data expert in this region and would like to be involved in the validation of this report or have any other inputs, please feel free to let us know. So next is the metadata inventory for the Southeast Pacific, our other pilot region. This research was undertaken by the Permanent Commission on the South Pacific, CPPS, to document regional, national, and local data sets that cover biodiversity and human activity features within the Southeast Pacific region. And on screen, you can see there are 4 countries that were included in this regional assessment. And for each country, a metadata inventory was created. In summary, valuable environmental information has been generated and collected from all metadata inventories. However, metadata inventories did not cover the same topics in all of the countries due to both differences in the country's data gaps and the degree of accessibility to existing data. There are common data gaps in invasive species and deep sea mining license areas. Species movement patterns, bathymetry, deep seabed mineral resources, fishing and tourism data are still difficult to be produced among this region. and there's an evident lack of deep sea data among the whole CPPS region. Colombia and Ecuador's inventories highlight important and detailed areas with particular biological environmental importance. I've now covered some of the background of marine biodiversity data and metadata, as well as preliminary results of metadata inventories in each of the pilot regions. I'm now going to move on to discuss some of the challenges associated with marine biodiversity data. There are, of course, many issues around marine data usage for decision making. And some of these include that 95% of the ocean remains unexplored. Secondly, there is still a strong bias in sampling effort and data availability towards temperate regions in the Northern Hemisphere, as well as within national waters. Areas beyond national jurisdiction remain comparatively unexplored due to logistical challenges and costs associated with sampling remote areas. In particular, deep sea habitats are presently understudied, and there are still many endemic species that currently remain unknown to science. This is why creating inventories of marine datasets, such as the ones created under this project, are so important to get an overview of what is actually out there and to increase the transparency of who holds what data. Access to and sharing of data remains difficult. Data are often expensive to collect, and sometimes data owners want to keep hold of their data. However, the global community is slowly moving towards making data more freely available. Here is an example of global marine habitat distribution. When you look at this map, our knowledge of ocean habitats looks quite complete, but this actually gives you a false sense of completeness, since most of the visible data sets here are modeled data, the seamounts in purple and the knolls in pink. You might also notice that these cover large portions of areas beyond national jurisdiction. Once you remove these modeled layers, we're left with examples of 5 habitat datasets. These are datasets that are curated by UNEP-WCMC, holding more than 2.5 million records over 2.1 million square kilometers. The areas beyond national jurisdiction look much more empty now without the modeled data. In the ocean, our knowledge of distribution of species and habitats is usually said to be quite good in the shallow coastal waters, but pretty poor in the deep offshore waters due to limited time and resources. There are biases or gaps in knowledge, which can be spatial, as shown here, but they can also be temporal, seasonal, or taxonomic. And as a nice real-life example, in April 2018, there was an article by Newsweek asking why we're mapping Mars before the ocean, particularly when mapping the ocean floor would cost the same as a single Mars mission. In addition to the data gaps and biases just mentioned, mostly related to the physical aspect of ABNJ, there's also the institutional or governance aspect. Traditionally, activities in ABNJ have been mainly sectoral. This means that each sector implements its own area-based planning tools, such as vulnerable marine ecosystems for fisheries bodies, or particularly sensitive sea areas for the International Maritime Organization. These sectoral area-based planning approaches have also resulted in data being created and stored sectorally, with sometimes little communication between the sectors. The issue here is that there's currently no centralized platform that we know of storing cross-sectoral ABNJ related data. So I've now discussed the general challenges with marine biodiversity data. Now I'm going to touch upon some of the data storage and sharing options in ABNJ. In the absence of a centralized ABNJ specific data platform, data storage and sharing is difficult for areas beyond national jurisdiction. We therefore very recently published 2 technical reports in which we explored what data storage and sharing options exist for the 2 pilot regions. We explored currently existing and potential future data storage and sharing options in the Western Indian Ocean and the Southeast Pacific. And these documents were published as part of the Areas Beyond National Jurisdiction Deep Seas project. We identified different data sharing and storage options in the 2 pilot regions and assessed them using a set of criteria that you see on screen. So firstly, we have mandate. Does the portal currently cover ABNJ or EEZ only, national waters? Secondly, we looked at sustainability. Is this an option that's viable in the long term? Thirdly, availability. Is it available now? And then we looked at functionality as a criteria. How easy to use is it? And finally, visualization. Can you map data layers online using web mapping, for instance? These reports allowed us to get an overview of what options currently exist in both the pilot regions. We assessed the range of options, including classical data portals to websites that simply list data and their sources. On screen, you see an example of the main type of results, here shown from the Western Indian Ocean results. This table shows how well some of the assessed data sharing and storage options met the predefined criteria. For example, if a data portal had web mapping services or not. Based on the results of this analysis, we were able to make some initial recommendations for data sharing and storage for ABNJ in both the regions. We differentiated between short-term options available during the ABNJ Deep Seas project, and then long-term options, which go beyond the project timeline. Next, we will consult with both regions during workshops, where data sessions will be held to discuss different data management options, as well as the issues and the opportunities. This will also shape the development of a data tool adapted to the regional needs and best adapted for planning in areas beyond national jurisdiction, given the current capacities and gaps. The report gives overarching recommendations which apply to both regions, but it also has regionally specific recommendations per region. Overall, the usage or adaptation of a pre-existing platform was recommended rather than creating a new platform from scratch. In the Southeast Pacific, SpinCam was identified as the best option due to its regional recognition and high relevance to the project. In the Western Indian Ocean, the best option was the Nairobi Convention clearinghouse mechanism. This was also due to its relevance for the project pilot region, as well as its mandate matching the project aims. On screen, you'll see the next steps in the project. There's also a potential proposal to develop a visualization portal which will allow the various relevant data to be viewed in both regional and sectoral views. It wouldn't be a data repository, instead it would be a tool to collate data from a wide range of different hosts, and links to data sources and relevant other information would be part of the portal if it goes ahead. So to summarize, there are many complexities surrounding the collection, collation, and storage of marine data, both within and beyond national jurisdiction. But the use of metadata standards can help improve understanding of the storage and the use of the data. As part of the ABNJ Deep Seas project, there's been a number of outputs, from global metadata inventories to regional metadata inventories, with the aim of better understanding what data sets are out there. We've also investigated how data are stored and how they can be shared and used between sectors. This work is ongoing through further discussions with each of the pilot regions. That's the end of this webinar, so thanks very much for attending and allowing me to give an update on the ABNJ Deep Seas project activities in relation to data and area-based planning. If you've got questions, please write them in the questions box and we will respond to you. Thanks. Hi, we just have one question, and it was asking for the metadata inventory for the Western Indian Ocean. So we would be very happy to send that out when it's finalized to anyone that would like any copies of these. So I'll put my email address on the chat box, and please feel free to email with any further questions or any requests for any of these reports, and we will get them to you. So if anyone else has any other questions, please let me know, and I will answer them either now or we can answer them in email at a later date. I'll wait another couple of minutes to see if anyone has any questions. Um, if not, then we'll end this webinar. And as I said before, please feel free to get in touch. I've put a couple of email addresses up in the chat box, so I hope you can all see them, but feel free to email. And we'll also be making these webinars, we're recording them, we'll be making them available online. So we'll email you with the details of where these webinars will be stored online. Okay, I think we'll end this webinar now. Thank you for all attending, and as I said, we'll send details of where these webinars will be stored online. Thanks very much. Bye-bye.